Hello everyone, my name is Griffith Hughes and I will be helping you solve the 2011 Calculus BC FRQ number 3. Here's what I plan to cover with this video. A quick review of arc length, the problem itself, common errors on the question, and a couple of extra practice problems that you can do on your own. Let's begin. When we look at a graph, the distance between any 2 points can be approximated using a Riemann sum. In this case, p sub I minus 1 and p sub 1. Those are going to be our 2 points. As we take an infinite number of points between the two, we know that the length will become the Riemann sum, the actual one, rather than an approximation, as you can see up here. The difference between the 2 points can be found using the distance formula. However, we can factor out the change in x to find that the distance is equal to the square root of 1 plus f prime of x multiplied by the change in x, as you can see down here. This formula has multiple variations. We can factor out the change in y instead, or leave it in terms of dx and dy over dt, which is very useful for polar coordinates. We're not going to see this dy format as much, but and you don't really need to remember it because it's easy to remember this first part and just remember that, oh, I'm factoring out the change in x or the change in y. Now that we've reviewed arc length, let's do the no calculator problem. 2011 number 3 has 3 parts. But first let's read it. Let f of x equal e to the 2x. Let R be the region in the first quadrant bounded by the graph of f, the coordinate axes, and the vertical line x equals k, where k is greater than 0. The region R is shown in the figure above. This is going to be crucial to our understanding of the problem. Alright, time for part A. Write, but do not evaluate, an expression involving an integral that gives the perimeter of R in terms of k. From the image given, we already know that this section is going to be a length of 1, this section is going to be a length of k, and this section is going to have a length of e to the 2k, so we don't really need to worry about that. However, this curved section here requires us to use the distance formula in order to find its length. Using our arc length formula, we know that the length of the curve is equal to the integral from 0 to k of the square root of 1 plus f prime of x squared dx. The derivative of x is 2e to the 2x, so our final answer is 1 plus k plus e to the 2x plus the arc length of that section. Pretty simple, right? Part B is the region of R is rotated about the x-axis to form a solid. Find the volume V of the solid in terms of K. The formula for volume or solids of revolution is pi times the integral from a to b of the distance to the axis or the line that you're revolving it around squared dx. When we plug everything in, we get the volume is equal to pi over 4 times e to the 4x from x equals 0 to x equals k, which you can see right here, which we can simplify to be pi over 4 times e to the 4k minus pi over 4. Easy peasy. Part C asks us to find the volume, or to use the volume V found in Part B to figure out the change in volume with respect to another variable t when k is equal to 1/2 and dk dt is equal to 1/3. So from the last problem, we know that the volume is equal to pi over 4 times e to the 4k minus pi over 4. The first thing we need to do is differentiate the volume, so we get dv over dt is equal to pi e to the 4k times dk over dt. Next, All we have to do is plug in the given values and solve, getting dv over dt is equal to pi e squared times 1/3. Not that difficult. Common mistakes that occur on this problem often involve squaring and taking the derivative. Always remember that the derivative of f is squared in the arc length formula, as you can see in every single one of these. It will always be squared because it's based off the distance formula, as is the distance from the axis when we're trying to find the solid of revolution. Oh, wrong part E. As you can see here. Remember to double check your derivatives for small errors, such as forgetting dk over dt in part C via the chain rule, because we'll often go and say, oh yeah, dv dt is equal to pi e to the 4k, but forget that we took the derivative of k when we brought it down since it's respect to dt. For more practice, I recommend taking a look at BC FRQ number 2 from 2015, 2014 number 5, 2012 number 1, and 2010 number 3. Most of these are speed problems or particle problems, such as like finding the distance it travels or finding turning points, but they are useful practice because they incorporate the solving for the distance and practicing taking derivatives, which is a useful skill in this problem. I hope this video helped explain the problem if you had any questions on it, and feel free to ask me in class if you still have any. Thank you.